What's up, Basical? What's up, Basicalers? Welcome back to our channel. So for today, we will learn about high order derivatives. Yay! And today we have our special guest. May I request our special guest, please? Yay! But before that, don't forget to drink your water. Drink your water! Yay! It's gonna drink the water. Bye-bye! So, for our first example, we need to find the third derivatives, given that y is equal to 4x cubed plus 2x squared minus x plus 2. So, we need to find the first derivative. So, in order to find the first derivative, we need to use the power rule. So, power rule states that d over dx, x raised to n is equal to n x raised to n minus 1. So, for our first term, 4 times 3 is equal to 12x squared. Since our n is 4 and our exponent is 3. So, 4 times 3 is 12, and we subtracted 1 in our exponent becomes 2. So, for our second term is 2 times 2 is equal to 4, and 2 minus 1 is equal to 1. So, 4x. And in this case, negative x, we need to observe the identity rule. So, the identity rule said that d over dx, x is equal to 1. So, we substituted negative x to negative 1. And in plus 2, we observe the constant rule where d over dx, where c is equal to 0, and c means constant. So, we disregard 2 since it's equal to 0. So, our first derivatives is 12x squared plus 4x minus 1. So, in order to solve the second derivatives, we will use the first derivative. So, 12 times 2 is equal to 24, and 2 minus 1 is equal to x. Then, 4 times 1 is equal to 4. And since it is understood that when x has no exponent, its exponent is 1. So, negative 1 is disregarded because according to constant rule. So, since our main objective is to find the third derivatives, we use the second derivatives in order to come up with the third derivative. So, 24 times 1 is equal to 24. So, that's why our third derivative is 24. So, for our last example, we need to find the fourth derivatives given f of x is equal to 4 sine 5x. So, for our first derivatives, you just copy the 4, then we use the formula of d over dx, sine u is equal to cosine u, derivatives of u over dx. So, in our given, the u here is the 5x, then u, in our formula, the derivatives of sine is cosine. So, we put cosine here. Then, based on our formula again, we need to find the derivatives of the u. Since our u is the 5x, we get the derivatives of 5x, which is 5. So, we just multiply the 5 and the 4. So, 20, copy the cosine 5x. So, our first derivatives is 20 cosine 5x. And for our second derivatives, we use the first derivative, which is 20 cosine 5x. Just like we did earlier, we just copy the 20, then find the derivatives of cosine 5x. So, the formula is d over dx cosine u is equal to negative sine u derivatives of u is over dx. So in this case, our u is 5x, and the derivatives of cosine is negative sine. So negative sine 5x. Since in our formula, we need to get the derivatives of u, we get them, and our u here is 5x, so we get the derivatives of 5x, which is 5. So, and we multiply 20 times 5, which is 100. And the proper way of writing is to transfer the negative sign on the beside the product, which that's why the answer is negative 100 sine 5x. And for our third derivatives, we again use the answer or the second derivatives, which is negative 100 sine 5x. So we just copy the negative 100 and find the derivatives of sine 5x, which is cosine 5x, and get the derivatives of 5x, which is 5. So 5 times 100, negative 100 is negative 500 cosine 5x. Since the main goal is to find the fourth derivatives, we again use the third derivatives in order to solve for the fourth derivatives. So the answer for our third derivatives is negative 500 cosine 5x. So we again copied the negative 500 and get the derivatives of cosine 5x, which is negative sine 5x. Then the derivatives of the u, or the 5x, which is 5. So again, multiply the negative 500 times 5 and 2500 sine 5x. And since we have two negatives, it will become positive. That's why the fourth derivatives is 2500 sine 5x.
So guys, I know that was really challenging, but I hope you did learn something today. If you do, don't forget to like, comment, and subscribe. See you on our next vlog. Bye!
Bye-bye!
Rinkis!
Rinkis